Evening all. How we all doing? Oh, we nearly missed the firsters. That's no good. Oh, it's Claire's fault, Delta. She was in the shower and I was sat next to her talking and she just wouldn't stop talking, so it delayed me. Sunday again. It feels like a week since it was Sunday. It's crazy how time flies. She does love to natter. Right, what are we doing? Caravella tonight, isn't it? Before I crack on with that, I will just show you a thing, what I have been working on. So every time I get bored, I try and do a little bit of work on planetary landings. So I've been playing with the Shader World plugin. It's probably what we'll end up going with as our solution for this. What I like about it is the whole thing is driven by a material graph. So we can do a lot with noise and things like geometry stamps and things to really shape the terrain. And it plugs into the existing PCG tools as well quite nicely, so that's good. But yeah, I just experimented with just adding a noise layer to a terrain, and then I overlaid a crater map on top of that as well. So what you end up is something like this. And the nice thing about it is it's fully procedural. There's no repeats, so there's no repeating pattern there. It's all completely unique terrain. What we need to do is, obviously, we need to take the map we generate for the planetary terrain as a whole, and then we need to use that as our base height map for the world itself. So that gives us our continental shapes, our ocean areas, etc., etc., etc. And then we do detail noise within those regions. So what you're seeing here, this is going to be all the detail noise that gets overlaid on top. So we can do things like, craters and that sort of thing. The region as a whole, I mean, at the moment this is infinite. So if I zoom all the way out, as we move, it's just generating terrain infinitely in every direction, not unlike how Minecraft does it. But as you can see, I mean, it's rapid. It's pretty much instant. So we can, if we were flying a shuttle, then, hang on, let's get down there at ground level. If we're flying a shuttle over this terrain, obviously we can fly a shuttle very, very quickly across this terrain, and yeah, it has no trouble keeping up. We can also change the size of the region that's being generated, so we can dial some knobs for performance. I mean, the clip map is pretty performant as it is. As you can see, it's LODing as we move in and out. But yeah, I think we should be good performance-wise with this. We won't use the existing terrain texture. We'll add a different one to that, but yeah. Yeah, it does actually, or dear, it did have terrain. I think I might have turned it off. Is that it? No, that wasn't it. Oh, there we go. I think I may have got rid of that completely. Yeah, I need to rebuild that back into it. Basically, I wanted to look at the terrain itself and get an idea for the actual terrain features, which is difficult to see when it's covered in trees and grass. But it will generate trees and grass all over this everywhere. And it works in multiplayer as well. So if I grab a couple of characters, there's player 1 walking around, and if I grab the other client window, there's player 2 walking around. So all the collisions and everything already work in multiplayer, which is good. Nice to have that working out the box. So yeah, so the way we're going to implement this is, again, the terrain region, as I say, it follows the camera. So again, it will generate infinitely in any direction. But if we're driving that with a base continent map, then we'll be obviously just stopping the edges at the edge of the planet. But we want it to be able to loop around as well. So again, as you reach the edge of the world, it will teleport you to the opposite edge and carry on. Technically, yes, this is fully moddable terrain. Like if you wanted to build, say, a village on this terrain, then we can use literally just a stamp on the terrain to change the geometry, flatten it out, spawn a village or something. So it is fully moddable at runtime. It's not voxelized, so you can't dig tunnels through it, but you can cut holes in it, flatten it, raise bits up, cut rivers through it, cut a road through it. You could draw a spline, and the road will actually flatten the area where the road goes. So it's quite flexible for what we need it for. It should be client driven, Honinani, but hang on, we can test that if we set the world size to something tiny. Let's make it smaller than that even. Obviously this would be one of our performance clamps, so for performance wise, if the view distance was too much, then we can just turn view distances down as required. If we make it, that's probably the smallest it will go. Okay, I'm just going to run this one miles this way. I mean, it should just follow this particular client. It's a very bouncy planet. Yeah, it doesn't seem to have any issue with where the other player is, so that's fine. But yeah, so if you imagine, obviously we'll do more work on the actual noise algorithm to make it more naturalistic looking. But you know, once we've got rocks being spawned, we'll use tessellated surface materials as well, so we'll have like detail, like pebble level detail all over the place. Yeah, we should have pretty interesting planetary surfaces. It did, I saw that, Oninoni, yeah. I don't know why the view distance went so big. I don't know if that's just the client, or is it on this guy too? Oh no, it's on both of them. You can zoom out quite a long way. again, we'll have a look at that. But yeah, in terms of generation speed, performance, and flexibility, I think this is definitely a winning solution for us. And the idea is that we will obviously spawn the terrain generating actor somewhere below the ship where you can't see it, and then it will follow the player around generating terrain as it goes. And then we'll use the X, Y, Z, so the X and Y coordinate of the player to determine where they are on the planet's surface. So again, this is going to be completely flat terrain. It's not going to be wrapped in a sphere. Basically for physics and simplicity and ease of generating it reasons. But you'll be running around that surface terrain, and it will be moving the skybox around based on where you are on that surface given your XY coordinates. So if you were flying in a straight line across the terrain, the sky is going to be rotating as you fly forwards to kind of simulate the fact that it's a spherical world. So it will feel like a spherical world when you're flying around and navigating the terrain, but in actuality it's a flat surface that we're just teleporting you around edge to edge. But yeah, as Ani Noni says, it will probably take a long time to reach an edge. But that said, because it generates infinitely in every direction, it will tile anyway. So the planetary surface that we're generating, when you reach an edge, will automatically tile anyway. So you'll see like the rest of the world beyond you, but it will teleport your player pawn to the opposing edge. So other than maybe a little flicker when you reach the edge of the map, it will still look like you're continuing your journey. So technically you can fly around the planet as seamlessly as you like. But yes, so we have completely seamless terrain. So if you were to see the player from above, this is what's happening. It's just generating that as you go about, and you get interesting terrain features depending on how good the noise is set up. Like, it's an interesting bit of a crevasse going through there. But what I like about it is, again, because this is all texture driven, using literally just GPU driven noise with clip maps, it means that we can do crazy things with the terrain. We can have deep canyons, we can anything that we can produce from the noise algorithm, we can generate on the terrain. So I want even our barren worlds to be like geologically interesting. Space is empty, of course it is. There's a lot of barren nothing in space. That's just space, that's what it's like. But even on the barren worlds, I still want them to be visually interesting. Like, I want there to be worlds where you've got like a particularly unique mountain or a particularly deep chasm that's kind of unique to that world. Yeah, or a certain type of geology which you don't find elsewhere. I've seen some really interesting noise solutions on Shader Toy. Let's see if I can find it. There was a really nice erosion noise function. See if I can find it a minute. Oh, yeah, some of these. So it was this one that I was looking at, purely noise driven. which is very cool. But yeah, there are various different ways that you can do erosion patterns just using mathematical noise, and some of them are like, you know, genuinely convincing, which is nice. So, you know, we'll have a look at some of the things we can do with that. You know, erosion algorithms tend to be expensive, but like some of them are really, really cheap. Like this one is the one that impressed me the most because it's really, really lightweight and really, really simple, and it does give you these kind of like eroded patterns on the peaks. So we can do something like this to do a final erosion layer on the terrain, and we'll need to use this for things like rivers and things as well. But yeah, so there will be solutions for that, and as you can see, you do get that nice kind of erosion pattern without going through actual, you know, erosion algorithms. It won't, Timmy, no. You won't be able to get high enough in the shuttle to be able to see curvature. Like if we extend the terrain a bit. Oh, hang on. Wrong box. Where was it? There. Yeah, so when it comes to how high you can get in the shuttle, obviously we need to do that shuttle to space transition, and we also need to do the space to surface transition. So the question is, where do we put the shuttle altitude wise? Obviously we're quite high up here. If we spawn in, say, actually got a ball here somewhere. Yeah, right. That is a 1 meter sphere. Right. So we know that sphere is 1 meter in radius, I think. So going up somewhere like this, I think this is probably about as high as we'd want the player to be able to go before we start doing that transition into space. I guess we want you to get high enough that you can explore the terrain, but not so high that the lack of curvature becomes obvious. There needs to be a balancing act there somewhere. Although all the interesting stuff is going to be down here. So the idea is that, you know, if the shuttle was, say, here when the transition is completed, then, you know, you'll be flying around in your shuttle looking for somewhere to set down. So say you picked this spot here, you'd land the shuttle, boom, get out, and then explore the surface on foot. And then when it's time to leave, you get back in the shuttle, and as you fly up and away from the surface, you'll hit that transition point where you'll get some kind of UI thing where it will say, do you wish to enter orbit? And then you just click yes or no. And that's what manages the transition. Yeah, this is a cheese planet. But like I said, the material functions for it are really, really straightforward. Like if I was to just do that, stick that in there, make that, I don't know, that color, pop that in there, and now it's all a different color. Not as interesting, obviously, but you get the idea. And similarly, with the generators themselves, did I break those pins, or did I? No, I left them as they were. That one I think it was. There we go. Yeah, so to answer the foliage question, you know, this is what it looks like when you start sticking biomes on it. You get lots and lots of stuff, but obviously that's just like spawning stuff within a given range on the surface. But again, it's rapid. We will be using nanite foliage with 5.7. So obviously right now these LOD into 2D trees, that won't be happening. There'll be 3D across the board. But yeah, you know, there's only so fast we can go, but it kind of keeps up. It is triplanar, yes. Yeah, so like here's a relatively steep edge, and you'll see that there's no stretching on there. This particular material's not using it, but I've got a really nice material function that does single sample triplanar projection, which is really cool. So you get the nicety of the triplanar projection without having to do 3 material samples. It only does the 1. It does give you a hard edge on the UV seams, but it looks much nicer and costs like 33% of the cost of a normal triplanar projection, which is nice. Oh, Sophie, thank you. Yet again, you are awesome. I can probably more easily just raise the sea up. Or maybe not. Should flatten it a bit. This is why I turned off the foliage, because it's difficult to see what the terrain's doing when you've got a face full of trees and grass. I lower that one down a bit. Yeah, there we go. There's some lakes with trees in it. Let's get rid of that a minute. Yeah, so again, all of this needs lots of tweaking, lots of refining. But yeah, it gives you kind of a rough idea of what a watery, pockmarked surface would look like. And then, of course, we can, in fact, get rid of that. And then we can get rid of them. Put that back up to 5. And that'll get rid of the craters. So now we've just got flat terrain. Ooh. Flat terrain, which interestingly LODs the water away. So that's something to investigate, but yeah. But I love these noise algorithms. They create some really, really nice shapes for the surface itself. Like when we start adding micro detail to the continental map, I love that it's got all this swooshiness in it. It's good. It's awesome that that's just purely coming from a noise algorithm. Not quite sure why the water is LODing itself like that, but never mind. Yeah, it does look that way, doesn't it? Let's mental it up a bit. I was hoping I could use power to make that a little bit crazier, but obviously not, unless I minus the power maybe. Yeah, that broke it quite sufficiently. Yeah, such is the fun of noise algorithms. We can create absurdity. Anyway, enough of that. Let's just fix that a minute. So I'm really excited about this, and I'm kind of really itching to get my teeth stuck into planetary landings. So I imagine that's probably what I'll be doing this coming Friday. I'll get into this some more, work out all the things that I can tweak and mess about with, see if we can start actually implementing some landings. I'll do the same as I've done for the shuttle for now. I'll just put like a teleporter in the armory on B deck, on A deck rather. So you'll just like walk through a portal and it will just stick you on the surface. And I'll have it automatically generate the terrain as soon as you're within range of a planet. So we'll probably use like the short range sensor range for that. So basically as soon as you can visually see the planet in front of you, we'll then generate the terrain and allow you to teleport down. I've been working on the brig stuff all day today on Inani, and that's pretty much the only thing that we have left. So the character spawning side of things for VR is also for first person, and the same with the multiplayer. So these two things here are literally just for testing, and we're pretty much there with it. The locomotion methods, basically I need to implement arm swing and teleport, and then that should be done. And then finally, I just need to make the pause menu usable in VR. I tried making it a fully 3D menu like the main menu is, but it was reflecting the menu off of like everything in the game world. Like as soon as you hit escape to bring up the pause menu, it was reflecting in the glass, it was reflecting in the ceilings, it was just, because it's screen space, it was just reflecting everywhere. Which is going to be an issue in VR, but it's kind of unavoidable really. I think ultimately we'll probably make like a little wrist thing in VR that brings the menu up there so you can just kind of tap a thing on your wrist. That's probably the cleanest solution for VR, but for now I'll just make a 3D version of the pause menu so that it's VR usable. And then that's it, that's everything that's left on the roadmap. That aside, it's all about bug fixing, which is what I've spent all week doing really, just sorting all that out. We got some really annoying multiplayer bugs. Like we had one where I'd say like 60% of the time when you exit a chair, it teleports you to the bridge ceiling. That is now fixed, it's no longer doing that, so yay. I've got an issue with customization. So when you log into a game, it's not automatically doing your customization. And then when you do your customization, you actually end up overlaying yours on top of the host's character. So like whatever you change for yourself, the host changes, which is really weird. So there's some replication like crossover there I need to fix. But yeah, I'd say that the main hold up now for putting this build out is literally just fixing the bugs. I want to get the nasty ones done and dusted before we release. And that will tick off these 2 boxes. Yes, yeah, the VR player will inhabit the same world as the non-VR player. So you'll see a VR person moving their arms around and doing all the VR stuff in the game world. For now, they are just the default UE5 like robot character. We need to change all the bones and things for the character mesh to work with the VR that we're using. That's just a job I need to get on with at some point. But for now, if you're in VR, you are a robot for now. But yes, you should see each other walking around and doing what you're doing aboard the ship. The only thing that I need to do differently is like when you teleport, I need to have it so that we maybe fade to black whilst the character does the physical movement, because what we don't want is the character kind of pinging around if you're teleporting in VR. And I've seen other games do that. They just fade to black whilst the character moves and then it shows the screen again. And then we can just make that an optional thing. I prefer arm swing, just swing your arms and you walk around. It feels much more true to life, I guess. It just feels more interactive and more immersive just to swing your arms and walk around. And that kind of helps with motion sickness as well. It kind of tricks your brain into the fact you're actually walking, or just using the thumb pads to walk around. But yeah, so we'll have thumb pad, teleport, and arm swing as our 3 interaction methods. And we've had quite a few people request keyboard and mouse VR as well. So we'll probably add that separately when you launch the game. So there'll be 2 options. So you'll be launching in first person, room scale VR, or mouse and keyboard VR. We'll just call it seated VR, which is what games like Elite Dangerous use. That's basically seated VR. You're not like supposed to get up and walk around, even though you can, and it's cool to walk around your cockpit. But yeah, we'll have those 2 options. Yeah, the issue with that, Frankie, is that it causes motion sickness. So if you teleport, and we'll use the nav mesh to determine where you can teleport, but if the camera smoothly transitions whilst everyone else sees the character walking, then for the person in VR, that can be quite nauseating, which is why a lot of games just fade to black whilst that's happening. But we'll come up with a solution for it. I've seen it so that sometimes it doesn't entirely fade to black. It just makes a small circle of view in the screen. And we'll make that a configurable thing. So in the accessibility options, we'll have various filters for VR to kind of help people with nausea. Yeah, there's no issue with allowing teleport. It's just all you're doing when you're using teleport is you're saying, I want to walk over there, and then the character will physically walk to that point. It's like those games where you click to move, like an old Baldur's Gate or something. But you're doing it in VR, so you're saying walk over there and walk over there, and then the character physically walks to that location rather than actually doing a snap teleport. And the reason we can't do a snap teleport is simply because you're inhabiting the world also with first-person characters, and we don't want players just pinging all over the place. Yeah. Not quite, Frankie. So there's 3 ways of doing it. So when you select where you want to teleport to, option 1 is the camera just transitions at the same speed as the character walking to that location. Option 2 is we completely fade to black for the duration of the movement to help with nausea. And option 3 is we shrink the view down to a little circle in the middle of the screen, again, to help with nausea. That's kind of like the best of both worlds approach. If we make that a configurable option, then people can choose which way they prefer. If they don't suffer from VR motion sickness, then just having the camera move is the better option because you get to see yourself moving. But a lot of people can't handle that and it makes them feel sick. So it's better to just either fade the view down to a single point or fade to black completely. Again, personally, I just prefer arm swinging around, but each to their own. Okay. Anywho, let's be getting on with some stuff, shall we? Yeah, Claire's one of those people that actually suffers quite badly with VR motion sickness, so the only thing that's worked for her is arm swing. Well, the beauty of VR is you don't need a ragdoll button, you can just throw yourself at the ground. Yep. Yeah, there's a lot of stuff I'm looking forward to. Just need to get on with it. Okay, so last time we looked at this, we were building the quarters, this one rather, just sorting out the bunks in the bathroom and getting an idea of what that would be like. What happens, Dave, is that the character uses the headset height to determine whether or not you're crouching or standing or crawling or whatever. So the closer the headset gets to the ground, it animates the character accordingly. So if you were to just lie on the floor, it would think you were kneeling. So you can like bend over and the character bends over. It can't quite handle prone yet, but it can move up and down depending on VR headset height. Yeah, watching Claire in VR, she doesn't just arm swing, she's marching on the spot at the same time. It's ridiculous to watch, but it stops her being sick, so it's funny. Yeah, exactly, because there's a reset button, so when you start the game, basically stand up straight, press the button, and then it will record where the head height is. Obviously it sets that at the height of the character, so like a small child playing it, if they press the button while standing upright, they will be 6 foot tall within the game. And then obviously, their up and down movements will scale accordingly to that height. Cowbeck, yeah, exactly. I love Weeble. I've been a huge fan of Weeble since the Badger days. Yeah, this potentially is too big, but once we start fitting it with internals, then we'll get a better idea for space. Like I've said in the past, one of the hardest things with designing for a game world is getting the human scale right. And it's difficult to judge human scale properly until you actually have stuff in the room. I mean, there's only going to be a shower, a toilet, and a sink in there anyway, so there doesn't need to be a huge amount of stuff. But it'll be fitted and all integrated and lovely looking. Right. So one of the things I want to do moving forward, both for this ship to some extent, and for the backer vessels also to some extent, is build modular pieces. And we started doing that last Sunday, where we were building these bits here. I don't think I'll do any more of that tonight, because I want to have a look at where the cabling's going. But I really want to start building Lego bricks for ease of future ship construction, and at some point long off in the future, the ability to do that in game. But I need to work out how we're doing infrastructure connections with that. There's a lot of complexity involved. So I think what I'll do tonight is we'll look at the power infrastructure some more, work out where the power is going to go on a per deck basis, and that will tell us what the prefab sections would need to be like in order to support that infrastructure. They'd also need like a facing direction as well in order to have things connect together. Yeah, exactly, Calbeck. It's we've spent a couple of hours this past week digging out some of my old Lego sets. I had a bunch of Lord of the Rings Lego packs, and crazily these days they're like 150 quid for these little sets that I had. It's mad. So we figured we'd dig out all the pieces. So it's been really fun kind of finding all the bits and putting them back together. But it kind of reminded me of how much I love Lego, and how much we could do something along those lines with this, and have a very, very large array of pieces that can be put together in a Lego-like way to build starships. Providing that they have proper infrastructure connections that all kind of fit together and work. That is the challenge of it all. Yeah, I like Space Engineers. I've not played Space Engineers properly in quite a few years now. But yes, like that, but more what's the word? More Lego-like. So like there will be like wedge pieces and curve pieces and like a like really specific pieces which will have its own hull plating. So it wouldn't be block based like Minecraft or Space Engineers. It would be more like Lego. So specific shaped pieces that connect together in specific ways, which is something else I'm quite excited for. But again, we need to work out design rules for that so that things connect together from a power perspective, and that also leads to the slight alteration of how the power systems work. In fact, one of the issues we have is if someone has a really, really low frame rate, then sometimes when they start a game, the reactor turns off kind of mid-loading screen because the frame rate's too low, and some of the electrical messages are not getting passed through quickly enough. So the reactor doesn't think it's got something that it needs and then turns off. Whereas if we had a pulsed system instead, rather than an event-driven system, then those messages are continually pulsing down the cables like once per second. So we'll have like a 1 hertz update rate across the whole system, which means that loading speed doesn't matter because a second later it's sending another pulse. So if something doesn't get through the first time, the second time it will. Yeah, Delta. So that would be why. If you start a game and the reactor's not running, it's because things didn't happen quickly enough. And it's difficult to program around that because it's hard to know, what the frame rate's going to look like on each and every client. So when the game's loading, you'll notice on the loading screen, it goes through a few electrical startup steps where first it initializes the pumps, then it initializes the chillers, and then it's initializing things step by step by step to try and smooth out the startup process so that we don't have that issue of slow clients not turning the reactor on. But as much as that's helping, it's still not solving the problem for really low frame rates. But a pulsed system would. And the reason we stopped using a pulsed system is because it was causing hitching back in the day. But I'm hoping that that we can do it more efficiently now, and make that a C++ system so that it's not relying on blueprints, just to make it even quicker and less CPU intensive. And also, I want each framework section to have a piece of cable. So there'll be one piece of cable that just is that long, so that if the damage is happening here, then that's the bit of cable you need to replace, rather than having one long cable, which would be damaged in its entirety. And also means we can put plugs on it as well. So we'd have a cable running through there, and then there'll be a socket on that cable that the ceiling light will be connected to. So we can break out with sockets on a per segment basis as well. There's a few benefits of doing it that way. Hey Don. Okay. Right, let's have a quick reminder of where we got to. So yeah, so we've got high voltage going in there, got battery power coming out here, and then we've got the deck distributors coming down here. So from the per deck distributor, we then need to work out where our other breaker boxes need to go. Yeah, so we need a junction box. Probably one for the aft section, and then like a midship section, and then maybe a forward section. So maybe 3 junction boxes, which handle the breakers for those areas. Just need to sort of logically section the ship into pieces electrically. That's interesting, Frankie. I'll look into that. Thank you. Yeah, the prices vary depending on what they are. I mean, I was looking at some Star Wars Lego, and as much as I love the Star Wars Lego, I can't justify the cost of buying it, because something like the Millennium Falcon or the Death Star is like hundreds of pounds. Or £734. The Death Star is £899. That's mad. Depending on where you buy it from, obviously. Yeah. So just, case in point, if you want to buy the Millennium Falcon, it's £734, which is mental. As much as I would love a Lego Millennium Falcon, I'm not spending £734 on one. That's just madness. Yeah. Oops, I forgot this is not Unreal. I don't need to select a level. Actually, just looking at the rooms we have here. So we've got obviously an engineering room there, and all we've got at the back there is the top of the shuttle bay. So we don't need any power going to that particularly, because we'll use the deck 3 power for the shuttle bay, I think. Yeah, so the aft section really is only these 2 rooms. As we include the lighting in the maintenance tunnels there as part of that section. Or, I suppose we could do port and starboard, but then what would the mid corridor be? Okay, well, if nothing else, we definitely need power going to this side. And that's going to have to come from over here. So I suppose maybe up and over the ceiling. Obviously we need power for the machinery and the doors, and a separate circuit for the lights. Not specifically, Frankie. It's what happens is when one of the cables, when it was working, is that when one of the cables received an electrical pulse, then that pulse was then transferred to the next downstream cable. So there'd be like a daisy chain. It worked a bit like an addressable LED system. So you'd essentially just have that daisy chain of electrical cables that just transmit a pulse all the way down the line. So it cannot happen more than once per frame, because that's just simply the way it works. So the message is received, then at the very minimum, 1 frame later, it's transmitted on to the next device. Actually, I'm wondering whether or not we put the breaker boxes in the maintenance tunnel for this ship. Although no, we can't for deck 1 though, can we? So we definitely need a distribution box on the bridge, and that's going to be all 4 cables from the main deck distributors, all 4 of them. I'll have to route them through probably the side wall here under the windows. It's not a bad shout, Delta. Yeah, hopefully. I mean, it was more. I think it's not so much the checks themselves that were causing an issue. It's more the fact that the receipt of the electrical signal was then triggering onward actions, and I think a lot of those onward actions were potentially redundant. Like a simple example, if a mesh is hidden or shown based on whether or not power is there or not, if it's constantly receiving like there is power once every second, and then it's showing the mesh or setting the mesh to be visible once per second, that's redundant. It should in fact be saying, actually, is it already visible? If so, skip. Don't do anything. And then we can save CPU time that way. I think there's a lot of that was happening. It just wasn't doing enough redundancy checks to stop itself from performing redundant actions. I found a bunch of that doing some of this brig code over the past few days. Like some of the original code I did for the brig, I kind of looked at it and thought, why on earth did I do that? But hey, we live and learn. so for the bridge, we need to assume that it's going to have all 4 deck distributors connected to it, which means we need a bridge power output on all of these. And the same for engineering as well. That's also going to need multiple power feeds, because there are certain things we never want to lose power unless it's absolutely like as a last resort. So I think we'll put a distributor in the reactor room. And I guess that needs to feed, so it's all the critical stuff like life support, that sort of thing. Although, that said, we also want the whole switching over and the gameplay aspect of switching power feeds. So we have that balancing act. Like, the more you do automatically, the less there is for the player to do, and you're directly taking gameplay away by doing that. So rather than having an automatic failover for life support, we'll have that as a manual switch. So we'll have switches for which battery feeds are in use at the time. So if like battery array 1 is destroyed, then you'll have to do a switch over to battery array 2 so that we can continue powering life support, that sort of thing. Thanks, Kabak. Have a good one. Let's move that down there, actually. Yeah, something the Magellan desperately needs is the ability to switch between arrays. So on the various quadrant or deck distributors, we need the ability to have another box where we can configure which battery arrays are going to which quadrant. So there's going to definitely be a more granular approach to that when we do another pass on that system, because we're lacking that gameplay of being able to switch those systems. All these tubes they're analogies for where the cabling is going to run. So we need to work out exactly which cables are needed and where they're needed, so that we can design the power systems and actually build the cables properly. I'm stuck in an engine. Because we need to work out the routing of all the infrastructure to make sure that the doors are in the right places and things aren't being blocked. And we had an issue with like the lift, and making sure that the lift up this stairwell has a free uninterrupted run, and we don't need to like route something where it is. Yeah, I think the free version of SketchUp's like just like a web version, and I don't know whether or not you can install plugins on it or not. What's the best way of doing this? Ah, okay, yeah. That'll be it then. Keep moving these around because I'm trying to find the best way of doing this so that the cables don't overlap. So that one can go like that, and the next one's this one. This is SketchUp 2025 that I'm using. I've not long updated it, to be honest. It was, I was using the 2024 version, but I was having some issues with that one, crashing. Although this one, fingers crossed so far, doesn't seem to have any crash issues. So yay for that. Oh, no worries at all. The one thing that I would like most in SketchUp at the moment is proper face-weighted normals. That's something it's sorely missing. Like, you know, for anything hard surface that I want to do, I have to do all that stuff in Unreal. And there's a bug with it in Unreal at the moment, which is causing it to drop material groups, which is really annoying as well. You need your tools to support what you're doing, not fight against you. Right, so you got 4 main per deck distributors coming from the battery arrays, and all 4 of those are going to have feeds going into what will be the engineering distribution box, and we'll use that for powering the reactor and the pumps and things for the reactor. It's just so that we've got everything we need to keep the reactor itself ticking over. And obviously the lights and engineering and that sort of thing. This is going to get very, very spaghettified. SketchUp is a yearly subscription, and it's a few £100 per year. I'm not a fan of the subscription model, but it is what it is. I do miss the days when we would own the software that we owned, but it's not the way the world works these days. I do, yeah, the annual one. Hang on. Let me log into the Trimble thing. They've changed their website. Now it's confusing. Well, I don't know what they've done to it, but you click My Products and it just takes you in a loop. I shall work that out another day. But yeah, it's the SketchUp Pro Yearly that I've got. Yeah, it's quite a regular question actually. Why do I use SketchUp? I guess because I'm doing CAD work. That's the easiest explanation for that. Yeah, I mean I've got Blender. I use Blender, but for the CAD work that I'm doing, I find that I can get things done in SketchUp way quicker than I can with other tools. Blender is obviously the superior choice for any kind of like organic modeling over SketchUp. I mean, SketchUp can do subdivision and such. I mean, that's how we built the ship. Like, this is our subdivision mesh here. But yeah, it's more about just experience. I've been using SketchUp for like a decade now, so I know it quite intimately. And for me to stop and learn Blender properly, it means I have to stop work and learn Blender, and I just don't have time for that, so I just carry on with SketchUp. I've yet to encounter anything I can't do in SketchUp, so yeah, the things that I know it can't do, like it can't do UV mapping properly, it can't do face weighting properly, but Unreal can. So fortunately, all I need to do is export the base geometry with texture groups, and Unreal can do everything else. Smoothing groups would be nice. Something Unreal complains about is that the FBX files that I export from SketchUp don't have any smoothing groups applied. So yeah, that's something it's lacking, but yeah, it's yet to cause us a problem. Have a good one, Daniel Jackson. Yeah, I think you're right there, Timmy. Yeah, they can just punch straight through the wall. I need to have a look at how we're routing through to this box over here. I'm very conscious of the fact that all the cabling is on one side of the ship, but it's kind of unavoidable. I mean, the only other thing I could do is have port and starboard distribution boxes. I mean, on the Magellan, obviously we've got the 4 quadrants, and that makes sense because the ship is circular in the middle. But for this ship, we could do port and starboard power feeds. I mean, we do have port and starboard RCS hardware that's all separate, so it would make sense to do that. And then we would just split the power down the sides. My only issue with that, like I said, is the fact we do have a central corridor, so we would have to pick a side for the power for that corridor. I guess I'd go port and just run it down the port wall, which is what I would tend to do. I always tend to pick left. And then these rooms would be powered by the electrical supply going down through here. And if I did do that, that means we can use the maintenance tunnel for that, because we can have the deck 2 and deck 3 boxes next to each other. There's a nice little alcove here that could be good for that. Oh yeah, I'm all for neatness, absolutely. Because actually, what we could do is, rather than having one battery array per deck, we could actually have port and starboard instead. So split that down the middle, have the port arrays and the starboard arrays, and each of those powering one side of the vessel. Which means that we can mirror what we've done here to the other side. And then maybe give the engineering section its own separate feeds from all four. And the same for the bridge. Just for redundancy's sake. I do like the idea of running the cabling down these edge pieces, because then we can just punch them through where they are needed. And we do have that maintenance tunnel that goes all the way down the length of the vessel. So it does give us a lot of scope for engineering work. Let's just give it a try a minute and see if anything's particularly in the way. So we move the input voltage down and pop these across. So we've got feeds in and feeds out. So we'd need an aggregator box on each side. So we grab that and that. Them there. So you'd have two feeds from those going to that box. These two going to that box. They'll then break out to the individual decks on each side. And each one of those will be fed by that. Yeah, so we've got the battery distributor there. Obviously, we're going to have to do a bunch of spaghetti management around there. Yeah, I definitely want a lot in the way of visual pipes and cables. And because these pipes and cables are genuinely relevant to the function of the ship, you need to be able to see them and interact with them, and ultimately fix them when they break. Right, so power in, power out that side, deck power that side, deck power this side. Yeah, so then we need it's the lighting circuits and the room power that are the interesting ones, because we need those individual breaker boxes. Yeah, so this would seem to be the obvious place to put them. Because we can have a breaker box that has forward, mid and aft on it for lighting and utilities. Although maybe we actually move the boxes to where they need to be. We are widening this, of course, so widening this makes it easier to fit a bunch of this stuff in here. I think we'll keep this section just for the pipe work. So if we make... So obviously you've got the RCS hardware and its support stuff there. So if we do the aft breaker box there, maybe. That gives us a bunch of cabling to put on this wall. And then the aft breaker box would power this room, and I suppose we'll have a separate box for the shuttle bay. Yeah, and we'll take power from 2 breaker boxes for the shuttle bay, because we'll need a redundant supply for things like the force field, so that makes sense for that. So there's that one. Actually, I have a mirrored group here, don't I? Is that it? Yeah. May as well mirror it while I can mirror it. So if that's the aft one, then we'll put the the midship one around there. That's going to be stairs down. So probably there. Yeah, so the path's going to come around there. We'll have stairs down there to deal with these pumps and everything. So the breaker box can go there. So that feeds this crew quarters, half the stairwell, and I guess also this half of sick bay. So actually let's maybe make that more in the middle. We've got obviously the weapon systems are all going to be there, and the RCS is going to be there, so I guess somewhere along there. Right, so that gives us our 3 aft, midship and forward breakers for both the port and starboard sides. And then of course we need, because we've got 2 decks there, so I guess we'll do 2 decks worth of boxes. Same with this one. 2 decks worth. And the same 2 decks worth. Right, so decks 2 and 3 can have their breaker as boxes in the maintenance tunnels. Just gives you even more reasons to go in there. Oh yeah, well obviously put them in the where you can actually get to them. So that takes care of those, and then we've got obviously deck 4. So that can be powered from the engineering one. Oh, congrats AJ, welcome to the Rear Admiral Club. Yep, the Admiral's yacht will be coming after we've done the Caravella. I shall make that the next one I do. Yeah, that is of course the final model for the gun turrets. Job done. I think we may as well put the aft distributor for deck 4 just like in the cargo hold. I mean, we could even put it on that wall, to be honest. There's nothing particularly happening there, so that could be somewhere for it. Well, we'll move it somewhere sensible once we start fleshing it out. Yeah, I think for the whole forward section there, probably stick it in the hydroponics. Again, I think with the hydroponics we'll probably stick 2 feeds into this box. Because redundancy is a good thing. Guess we'll do similar for deck 1 as well. So we need power for the battery room and the stairwell. So I suppose really the deck 1 distributor can just go in the battery room. Seems a sensible enough place to put it. And then we've got science labs there. And obviously the bridge at the front. So the bridge can have its own. And then we'll need that separate one for the science labs. Depending on how we partition that off. I'm tempted to make a conference room there with just one lab at the back. So I'll have a corridor down through to the labs, the conference room there. I think we'll still have maybe like a tactical table or something in the back of the bridge. And then more of a conference room there for more crew relevant discussions. So if we're doing a corridor, then that can go in the corridor. Oh, real whiskey, of course. Let's move all this to deck 2. That's better. Let's see what we're doing now. Can't wait to do a properly finished cutaway diagram of this ship, where we can see all the the finished cabling and pipework and tanks and everything all exposed. It's going to look all kinds of epic. So, because these two boxes, I need to feed these 2 boxes. Yeah, I think we have to have both of them come up and over. We're not going to have a lot of room above the door, so we could potentially route some things across the ceiling. Yeah, so I guess some of it's going to have to go and follow these cables through this way. So those 2 boxes and those 2 boxes are going to follow these cables. So that's going to be 4 of those. So 2 more there. 2 more there. Actually, let's give that one the right color. It's a lower voltage cable, so we don't want the full voltage. So that's those 2. And those ones route to those 2. And then these ones are going to have to come along this back wall, I think. and we will try and expose as much of this as we can. If I can get the camera out of the engine. So it'd be nice to see all these cable runs like visible. So that's the input feed. So then we need output as well. These were on the mirrored group, but obviously not. So let's make sure that we add it to that lot. And it puts them on that side too. Oh yeah, I forgot that side was slightly off center. Need to realign that at some point. Hopefully that's back into alignment. Right, so if I get rid of walls a minute, if I get rid of these boxes, add them to the mirrored group because we want them to be the same on both sides. Right, so all four of those need to punch through the wall there. We also need an extra two for these ones. So, okay, so we grab that. So we've got aft port and starboard outputs on there, plus probably an extra one or two. But at the very least, those three. And then we also need the same on this one as well. So we're going to have to definitely do some rerouting of some of these cables. So for anyone just tuning in and wondering what on earth is going on in this stream, this is the fun that you have to do when designing Starship infrastructure. The real kind of like tedious cabling bit where you have to work out where the cable's actually going to run, and does the layout make sense? Do we have enough redundancy? All those questions. That's what we're currently working out, which is kind of a long but necessary task. Just to work out the most efficient way of doing this. So they obviously need to come through like offset from one another. So that one's easiest because it's just going to the aft section. If we make the top one aft, then we've got I think we made the bottom two, yeah, the bottom two for there, so obviously they're going to different decks. To make sure we get the right decks. So that one would be that one, as would that one. So maybe then, actually in hindsight, maybe we need to split them up a bit more like that. So that's forward section goes all the way to there, mid section goes to there, and then aft to the bottom. And the same with this one. So we bring that out to there. So we've got the forward section there. I'm wondering whether these should be the other way around. Because if we're doing like deck 2, deck 3, and then deck 2, deck 3, then deck 2 was the first one. Oh, that is right. Yeah, there we are right. Okay. Right, yes, we've got the downward run as well, so we need to go there, 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 because there are 3 of them. Hopefully that's still within the wall. Yes, it is. Which means so 4. So the last one. So the last one is aft. So forward, mid, aft. Which means that one also has to be level with this one. Okay, so which means that one connects with that one. That one connects with that one. That one connects to that one. Then that goes to there. Needs to be moved over there. That gets moved there. Right, that's all a bit of a spaghetti mess, but so forward there, both going into the top port. Midships there in the middle. It's that one. Midships there in the middle for that one, and then the bottom one is aft on both of them. Right, so those two, they need to go over to these two. Those ones are all connected up over there. think, given there's only 2 cables now, up and over is probably easier. Though we do have a sloping ceiling here, so that's slightly awkward, although actually, yeah, again, we're extending this out by about 1.5 meters, so that slope should vanish from there. So we're to move those over there. So we want deck 2 on the left. So that would be that one, I think. Yeah. So that one needs to go further over, which means that one needs to come up there. Yeah, don't worry. Once we're happy with the layout and we actually do these pipes properly, I will use the spline to properly turn them into actual proper cables with like plugs on the end and everything else that they need. This is just so we know what on earth it is we're doing. Right, so that's all good from that side. Yeah, and then from this side, that one needs to come out a bit further than that one. Yeah, so that's the outer line of the hull there. So that's going to poke through. But again, when we move that over, that will no longer be an issue. Right, so if we turn the decks off, it should have duplicated on both sides. It's starting to look like a thing. Yeah, similar issue there actually. The curvature of the hull is it's obviously going within that framework, so that all needs pulling out as well. But it'll do for now. to work out which one was the forward one now. So deck to forward is that one. So that one, that one, that one, that one, that one. Yeah. Obviously, when we do our final properly splined up cables, then we will contour them to the curve of the hull, like we did with the with these ones. We'll actually have it so it like properly follows the contour. But for routing's sake, I think that will do it for now. Should be both sides done. Right, so let's just retrace this a little bit. So we've got our main aggregators for the batteries there. So these two connect to that one, these two connect to that one. So we've got 2 arrays per side of the ship. So then we've got our individual deck distributors there, and each one of those has cabling going out to actual supply distributors, and they're reasonably evenly spaced. These ones could actually move to be more in the middle if need be. I mean, why don't we put it in the exact middle? That would make sense, wouldn't it? So we know that the exact middle of the ship is there. There we go. I will do, yeah. So once they're in game, I'll have different coloured cables for different purposes. Like the high voltage ones will be a different colour. They'll have high voltage symbols on them, and they'll be thicker and chunkier. The lower voltage cables will be sufficiently thinner, and have different markings on them. I don't think we need to distinguish port and starboard colouring wise, but I think we'll do voltage based colouring rather than location based colouring. Okay. So now we need the individual like lighting circuits and hardware circuits. And that's of course per section per deck. Oh, I think a Haynes manual-esque type thing is definitely needed. Like I said, when we do the technical manuals, and every ship will have one, yeah, they're going to be very, very detailed and go into a lot of really kind of granular stuff, and with lots of cutaways and lots of diagrams, and also what we're building here is also forming the basis for what will be on the holo display. So the idea is that if you bring up the ship systems on a holo display, you'll get a hologram that looks like this, so that you can actually see each and every ship system in isolation. So you'll be able to turn on, like, show me the power network, show me the the coolant groups, so you can see different layers of the ship's hardware, all exposed in 3D like this. And of course, if anything is broken, it will be flashing red on the holo display, so you can see exactly where on the ship something is damaged, and then, you know, obviously send off a repair crew or go and fix it yourself. Yeah, I mean, we can definitely do lighting circuit and utility circuits different colors. And yeah, as Max says, they don't do that for houses, but no reason why not. Me too, Jim. Me too. So the way we're doing this on the Magellan is we've got a lighting and a utility circuit running down through the corridor walls, and then we have spurs coming off of that for individual rooms and lights. So we need to do something similar here. It's really just a question of where we do the demarcation points. I think the midship ones, it's basically the main stairwell, these rooms here, although probably not this one because this is the engineering room, so we'll have probably a separate supply for the engineering room. This is really just like domestic stuff on the ship, it's not the actual hardware. So I think I think I might bring the cabling round the front first, and then just have it run down the length of the ship, one cable on either side, and then they'll spur off into the individual rooms and they'll end there. We'll have to think about the HVAC and how that's routed as well. Yeah, and for the midship one, maybe we'll go the other way. Because the question is, like with the main stairwell, do we have like the lights on this side on this circuit and the lights on that side on the other circuit? I guess there's no reason why not. They can still be connected to the same switch. They can just have a different power supply. Yeah, so obviously the lift will require power, and we'll have a separate cable coming off of the box of the lift, so that makes sense there. And we could potentially split this box. So 1, 2, 3, 1, 2, 3. I suppose. So if we've got 1, 2, 3, 1, 2, 3, and 1, 2, 3 sections, and really these two boxes per deck are only powering that bit, which means these boxes also need to power this bit. So maybe we need 2 rings, one going that way for this side, and one going that way just for that pretty much just that corridor on this side of the room. When it comes to the like the light switches, I'm having them work more like smart lights. So the lights don't care where they get their power from, because the light switch isn't a physical isolator like a normal light switch would be. It's more of a logical thing. So the control panel on the wall isn't switching a breaker, it's actually just turning the light off. So the light is still powered, it's just not on. So that being the case, it doesn't matter where they get their power from. So if this side of the room is on a different cable to this side of the room, it doesn't make a difference to the switch, because that's just a logical on and off, not a physical on and off. Yeah, boo, Edison. Yay, Tesla. I was cursing Edison the other day because I needed a light bulb, and the light bulb I had was an Edison screw bulb, and I needed a bayonet fitting. So I was like, grr, Edison and your screwing light bulbs. So just add a bit of complication to this. There's going to be windows here as well, so the cabling needs to navigate the windows. Guess we need a different colour for these, because these are the final ring. So what have we got? We got dark red, salmon. I suppose like a pinky colour. I would absolutely love to get a tour of a real running naval vessel, so that I can really geek out over the engine room and look at the electrical system and how it's all done. In fact, I would love, if anyone out there is listening that can make it happen, I would absolutely love to actually run through a full cold start of a ship, like a big cargo ship or something. That would be fascinating. Actually, let's do these completely different colours because I'm going to get confused otherwise. Right, so we'll do a yellow one for lighting, and then I guess a brownie one for utilities. And then we're going to need... Actually, that's on this side, isn't it? We're going to need that twice. Because we've got these two rooms, half of this room, and this corridor. So if we have one cable running that way, or one set of cables running that way, and the other one running along here, then that gives us all the spurs we need for this room and these ones. And then on this side, we could potentially take a similar approach where we have one going that way for those rooms, and then one coming that way. Although, no, that'll do actually. And then when it comes to the corridor, I think we'll just assume that anything central, we'll just use the port supply. Yeah, I hope that works. Yes, everything will be physical. So, like these runs of cables will be segmented. So they'll actually be running through a lot of the bulkhead sections. So every time you get like a framework join, we'll have a separate cable between the two. And that's also where we'll have sockets and things on them for plugging stuff in. But yes, each of those will be fully fixable. I guess that won't be the case for all of them. I guess in some cases, like these main supply cables, we'll probably have one cable that runs all the way down here. But where it punches through the wall, that would be a separate piece. So that bit would be a separate thing to repair over this bit. And obviously, damage that the ship takes is locational damage. So we draw a sphere of damage, and anything that's caught up within that sphere takes an amount of damage relative to how close it is to the middle of the sphere. So you'll be losing individual pipes and cables that need individual attention. That's very cool. Right, so we've got... I think we'll just have to label these like lighting 1, utilities 1, lighting 2, utilities 2 for the two runs that those cables are actually going to go down. And the same with these ones. This one's going to be slightly more awkward because of where it's positioned. We might have to take some cables over here. And to be honest, some of these devices can be powered from these boxes too, I think. And we've got electrical power there, so we may as well plug them into it. Yeah, then maybe carry it down this corridor. Definitely, AJ. When it comes to the military vessels, they're going to be built very, very differently to this. They're very much going to be utility foremost and comfort second. So we'll probably have a hardened central hull that contains all of the hardware, and then the outer areas will be for like crew quarters and things where damage doesn't matter quite so much. Meat shields. Speaking of whiskey, I picked this up a couple of weeks back. Jack Daniel's Apple. It's actually really nice. In fact, now it's in my hand, it would be rude not to have some. Excuse the bottle, I haven't got a glass. Really, really nice. Cheers. Trying to get my head around which way round this needs to go. So I would have to go that way. And I'll basically go about in the middle, because again we're going to have downward facing windows in this section, so we'll have some seating around here with windows that are facing down from the hull, so we're going to have to put the cabling above the windows in that case. So that means we'll have a lighting circuit that goes basically to there. And I say circuit, but the way we're doing the cabling in the game is the circuit is contained within the conduit. So this would be both the positive and negative, and it would loop at the end. Thus forming the circuit. So they're basically single circuit conduits, if that makes sense. So the lights will take their power from there, as will the doors. But to be honest, the utility one need not go all the way to the end because it's only needed by the door pretty much. Yeah, and then anything we put in here, maybe we'll have it go over the door, but we shall see. Okay, that one will go that way. And this one definitely does need to go around the corner, so bring that through there and there, so that needs to go to there. So obviously we'll do this up and over the door frame when we actually do it for propers. Now it essentially just goes to there. An end to that in there somewhere. There it is. Great. So the doors on this side will be powered by this cable, doors on that side by that cable, lights down the middle by this cable, yeah, this corridor by this cable. So this is where we need to move these over, otherwise they're going to overlap with each other. There's that one. Move that out the way. Move that out the way. That one connects to that one. So this one's a bit awkward because obviously the yellow one's underneath. I'll just let them overlap for now, but obviously when we do all the cable routing properly, that will need to not do that. Right, so that should be the midship ring 1, ring 2. Wondering whether or not we need a ring 3 on this for this section. I think we probably will. Definitely here because we need it for the pumps and the chillers. So this is definitely going to be powered by that. I suppose technically these pumps are in the midship section, so yeah, so we'll add lighting and utilities for this section. Chillers can be powered off of these ones, and I'm sure we'll have something over here that can be powered off of these ones. If it is just the pumps, then we'll probably just mark it pumps on there. Most of this is still relevant, to be honest, up here, so they should be at a low level on most decks. We want them to be kind of crouch height, So when the panel's removed, you can kind of crash down and work on them. Yeah, we could do. It's just when we do the UI and everything for it, we'll do it in rings. So we'll have ring 1 lighting, ring 2 utilities, ring 2 lighting, ring 2 utilities, and the UI kind of needs to line up with the outputs. And it'll be nice to just keep it consistent like this. The actual cables themselves won't be this thick, so it'll be easy enough just to have them go over each other. Once they're all splined, it'll be a nothing burger just to wrap them around each other. It won't be a big deal. Although we do have a similar problem here. Obviously those ones need to go around that as well. I've said nothing burger for a long time, I think. Well, at some point, Kaji, I want them to be openable so you can see the internal bus. It would be nice if we had like physical breakers and like physical like bus bars and things on the inside, which themselves can be subcomponents that break. Because as much as we'll have like this box is broken, it would be nice to be able to say like this breaker is blown and you can't just reset it, it's properly blown. You need to go and replace it with a new one before you can use it again for power. If you mean the full circuit is contained within the conduit, then yes. Might swap these two around actually. Yeah, so yellow is lighting, brown is utility. Yeah, these ones make more sense the other way around as well. I'll assume the physical connection for now, just to save messing about with it all. I will fix this. Knew that would happen. Right, so that's them. I think spherical chickens is a fair assumption to make. Thank you, lad. Very much appreciated. Yeah, so again, those need to come up and over the door, and we'll actually bring the cabling down to about there, so that it can be accessed by the crew. And I imagine like from here to here will be one section of cable, and then from there to the box will be another section of cable. Good to know. I like it when we achieve accuracy just through sheer fluke. Yeah, we'll do vertical farming and the hydroponics. I don't know what it is we're growing. It's going to be some kind of GM crop that's very kind of fast growing, high in proteins and high in everything that the crew needs to survive. Because again, the plant crop that we grow is the fuel for the 3D printers. It'll be converted into pellets. Same applies for both, though. They're both designed for deep space exploration. It's just that the Magellan is a lot more proficient at it. Right, leave those like that for now. Ooh, lighting circuits. Right, so we got ring 1, ring 2, ring 1, ring 2. And then there'll be a third ring of some kind for this. And then we'll have, yeah, ring 1 corridor, ring 2 shuttle bay. And a third ring for that. So in the grand scheme of things, there isn't a huge amount of cabling on this ship. Obviously we'll have the drop cables from the ceilings coming down in the walls to plug in to these cables. But that aside, That's pretty much it for the main trunk cables. Yeah, so we did our 2 high voltage ones for the RCS and the weapons already there. Which, to be honest, do need representation, so we will copy that up. So obviously these will be powered by giant capacitor banks. So a lot of this space here will be filled with capacitors for the weapons. So the power cabling won't go directly into the weapons. It'll go to the capacitors, which will then go into the weapons. And we need, I guess this space here will probably be filled with like the railgun loading rails and like the magazine for the railgun. And then that one would be the RCS, which will go about there. Right, and then we have to fit this one in. I mean, we could perhaps maybe run some cables up from there, but maybe it's more more resilient to have a separate run entirely, so it's physically isolated from these, straight back to these boxes. Yeah, I'm wondering whether or not to actually power those. So rather than having 4 feeds here from the different deck distributors, just have 2. And then we'll take a feed from each of these aggregators. So we'll have the 4 deck feeds plus an extra one on each side for the bridge. So what we can then do is we can then have physical redundancy each side of the ship, and then we can have cables coming in both sides of the bridge to power this box. So we'd have one coming in from that side, and we'd have another one coming in from this side, which could go up above the door. Yeah, we can do something like that, so that then the bridge has completely uninterrupted power. You'd have to lose both power rails, both sides of the ship, to unpower the bridge, which I think would be a nice way of handling that redundancy. Definitely need, as much as we've extended this ship to make it bigger and bigger and bigger, we still need like a computer core. We don't have one of them in there yet. That's going to have to squeeze in somewhere. It needs a server room. Yeah, that's not impossible. Or maybe at the back of the bridge, so we could have a bunch of server racks back here doing some data stuff. That's not impossible. Although I imagine that'd be quite noisy. Let's see if we can squeeze it in somewhere. We kind of need to just like extend the ship by one segment. Yeah. Yeah, the recovery room's going to be this one. So we'll have the actual like operating theatre and diagnostics area on this side, and then we'll have the actual ward and recovery area on this side. Yes, there's a corridor going up through the middle, but that's kind of unavoidable. And it's no biggie just to walk across the corridor. At least it won't be when I remove the cables. Size-wise, I mean, you can probably do 5 beds in there. I mean, we need to have like the CMO's office on this side. Although, saying that, I mean, the Doctor is, again, given that there's a small number of crew on this ship, a lot of people are going to be dual rolling. So we won't have a dedicated chief medical officer in the same way that the Magellan's got one. We'll just have a doctor and probably an assistant who do all the work. Yeah, I want to keep it intimate. I mean, this ship has already got way bigger than I ever intended it to be, by virtue of the fact that we just need rooms for stuff. Like the side rooms on here were for life support, water recycling, sewerage, the HVAC, all that stuff. Obviously the reactor room speaks for itself. We really don't have enough tank space for fuel and coolant, so we're going to have to bulge underneath for some of that stuff, including the fuel scoop hardware. But yeah, I mean, we're already really squeezing things in as much as we can. Like the fuel tanks for the engines are going to have to be in the pods. So the engine pods themselves need to grow a little bit. These ones are too small for the purposes. The green and the purple tubes there are supposed to be fuel tanks. But there's like literally nowhere for the player to go, so these just need to be made bigger. So we'll have slightly more expansive engine pods and a slightly bigger FTL ring around the outside. And if the worst comes to the worst, and we absolutely run out of space, then we can just extend by one segment forwards and keep the rest as is. But this is this is an interesting practice run and experiment at building a small ship and a compact ship, and building a vessel with a specific mission profile in mind, and trying to fit in everything that's needed for a vessel of this type. Just as a thought experiment, it's quite enlightening. And it's nice that we have like the math now for the cubic volume of plasma needed for the generation of the electricity we need for an FTL ring of a given radius. It's now that we've done the math for that, it's going to help with future shipbuilding, because we can build the ring and the reactor to a proper consistent scale, and then we'll know exactly what utility is needed for the actual movement of the ship, and then powering things like weapons and shields. So I really want to be able to make just like a 5 crew ship. I love doing 5-man groups in like World of Warcraft, for example. They're small, they're intimate, they're easy to manage, and I think it would be really cool just to have something about the size of the Millennium Falcon or Firefly. Something that has a small crew, everyone kind of mucks in and gets involved, but it's actually really challenging to build something that small and have it be capable of doing the mission profile that we want. Like, you need a hydroponics, you need space for that, you need the reactor room, you need all the supply rooms for the reactor. There's so much stuff that's needed in order to build a vessel to do the things you need it to do. And I guess, you know, in sci-fi, those things are never really thought about. They just design a ship, it looks cool. The scale of the ship often fluctuates throughout the course of a sci-fi show, and nothing's ever done to this amount of detail where we're literally thinking about where the pipes and cables have to go. Which is why, you know, I love this project for that very reason. And it's why I started the project. Building this stuff as if it were real is, yeah, it's absolutely fascinating. Yeah, that's true, actually. Yeah, the Romulan warbirds and how big they actually are. And there's a few different ships in Star Trek that have never had truly consistent scaling. And not just Trek, but other shows as well. It's like, yeah, things in sci-fi just work because they need to work. They don't work because of any logic. Speaking of logic, I've just realised that these cables are too long. Okay, so I think for the aft section here, I'm just thinking about where the doors are located and where the power needs to run to. Obviously that room's going to have a lot of hardware in it, as is this one. So I guess we need power this way around, maybe all the way around, to be honest. So the door gets power from that loop, and then this one can run this way for powering the shuttle bay. Yeah, and we'll do the lighting and such from here. Maybe actually we'll have, again, if we have a separate power grid just for engineering, a lot of that can be redundantly powered. Certainly for the main stairwell and the reactor room. The nice thing about this ship is that it is practical to build it in the real world. I mean, it's only 100 meters long, so it's not, we're not talking a massive ship. There are plenty of boats bigger than this. So, you know, it would be something you could build. Obviously, it wouldn't have a fusion reactor or a FTL drive, but physically you could build it. I think I'll I'll bracket this cabling underneath the stairs. So I'll have a circuit going that way, because that's just lighting and doors that way. Then a circuit coming this way. And we'll need to have the shield generator hardware for the force field that goes across there. So I'll probably pop that behind one of these walls here because you've got space for it. So put that hardware there. Might give that its own power supply, to be honest. See you, CSI. Have a good one. Yeah, I imagine it would still be quite pricey to build. Actually, if we come to there. Again, I won't worry about overlapping cables at the moment because we can sort that out when we actually build them properly. So I'll probably do all of those horizontally in like a cable tray, and I'll have a cable tray running, probably suspended from the stairs underneath, and then those will connect through to that box. So I'll have those ones there. Those ones running that way. Yeah, big old LED brake lights on the back. Yeah, because we're going to have things like 3D printers that are running in the shuttle bay, so we'll probably have those connected to this circuit. Like repair hardware, charging stations, that sort of thing. So that can all be powered by this. I think I will power the force field, probably with a couple of individual feeds off of the aggregators, so that it's on its own independent supply. Because the last thing you want is the force field failing because someone's turned off a breaker box over here to do some maintenance, and then everyone just gets blown out the shuttle bay. But yeah, I think the if I do that a minute, I think the ceiling lighting, even though we've got the cabling coming through here, I think we're just going to have to drop the cables down and do the ceiling lights based on the fact that this room is technically deck 3, it's just taller. And keep it on the deck 3 power supply, because that's where people are actually walking. Yeah, exactly, Timmy. So that one's got power. I think we will continue this one round here actually into there, because of course we've got this room and this door that need power. That's not needed. Shuttle bay's all right there. And yeah, then we need a feed from there. So we do have a bit of a cavity that we can work with on this side. I mean, it's not much of a cavity. But it is above the shuttle bay. Yeah, it's going to have to come down through there. And then we'll have yeah, we'll have force field hardware that runs around the door, in front of the door on the inside, and then we'll have like a concertina door that on the outside, because we need to make this gap as wide as possible, because shuttles are barely going to fit otherwise. Okay, so we need one for the bridge, one for the shuttle bay. Actually, if we stick that in our mirrored group, then we get the same on both sides. Yeah, these aggregators are going to have a lot of stuff coming out of them, so a lot of the main distribution work is going to be happening in the battery room at the back here. I think I might move that hardware more to the front of the battery room, just so it's not like literally hanging off the back of the ship, because in many respects, well, in fact in every respect, these two boxes are what are powering the bulk of the ship, and they're literally right at the back in a very vulnerable spot, so they kind of need moving. I might move them to that back wall. At least they're there then, and then we'll put extra armor across the back to make this a really kind of hardened shell. Didn't want to move both of them. Something like that. Obviously we will wrap it round gracefully. It will have like a power node on each side, and then both of those will power the full force field ring, so that it has a redundant supply for safety reasons. So the bridge one kind of needs to go through there. Obviously we've got the stairs going up there. To be honest, we can do a similar thing for the bridge one actually. We'll just take it through. There we go. That gives us our redundant bridge power supply going down each side. Again, there are going to be windows here, so we'll need to route that down underneath the window frames. But at least it gets us to nicely independent power supplies to the bridge. May as well join them up just for the sake of it. Right, so what does that look like then? Yeah, it's definitely looking a lot more nervous system-y, which is what I was hoping for. It's going to be nice to do a rendering of the ship where we're removing everything except just the girders, so so it would just be like that. So we'll see like the skeleton of the ship but with all the hardware in it, which would be quite cool. I think with the right lighting and everything, that would look particularly awesome. Okay, so bridge has its power. Force field at the back has its power. Should be deck 3 has its power, other than the bit that goes around the room. I suppose we could just do that real quick. Actually, no, that was deck 4, wasn't it? Ah, yes, of course. That needs to go in that wall. You're welcome, Festus. I always kind of feel a bit bad doing these particular streams because it doesn't feel like I guess a terribly engaging thing that I'm doing. I mean, it's necessary work to work out what on earth we're doing with the infrastructure on the ship, but it's yeah, it must be like watching someone paint a room or something. Well, I'm glad you enjoy them. I enjoy doing it, so that's why I'm doing it. Thank you, Max. I'm glad you enjoy watching the monotony of laying pipes and cables. Very much appreciated. I'll plop that cable there for now because it needs to go up over the door. Yeah, that's better. So it means that those two engineering rooms on each side are fully surrounded by power. Yeah, what I really can't wait to get done is getting this onto the holo display. So obviously we'll do a more detailed model of it, obviously. We'll have all the hardware there represented and have it all color coded and aware for damage states. It's going to be so cool being able to rip apart the different layers of the ship on the holo display and really kind of delve into the physical situation that's occurring on the ship. It's going to make combat and then the follow-up repair tasks hopefully really engaging. Or any other non-combat related damage. Well, I think with that is time. So I shall leave you with a view of the ship's innards. Love it. Okay, well, have a great week ahead, everyone, and I shall be back on Wednesday for more work on the Magellan, and then on Friday, where we might have a crack at getting some planetary landings done. I'll see what I can do in my spare time during the week. Don't really have much in the way of spare time, but when I can grab an hour here and there, I will see if I can get to the point where it's ready for some kind of implementation. Boots on the ground would be amazing to achieve at this point, so yeah, we'll see what we can do with that. But yeah, have a great week ahead, and I shall see you on Wednesday. Bye for now.